Hello everyone and welcome to another video. In this video, we're going to do one case-based question, and this is from the chapter Real Numbers. So we can see this is our case, and based on this, we have these questions. Now let's say if I read the case over here, it says 105 goats, 140 donkeys, and 175 cows are to be taken across a river. And further, it says that there is one boat, there is only one boat to make this trip. In order to do so, the lazy boatman has his own condition for transporting them, and he insists that he will take, this is important, same number of animals in each trip, and they have to be of same kind. Further, he wants to minimize the number of trips, and that's why he wants to take the largest number of animals in each trip. So now what we are going to do here is to see the first part, right? Let's say if I read the first part over here. So in the first part, the question over here is how many animals has to be taken in each trip. So we have to find out the number of animals that has to be taken in each trip. Keeping in mind it is the same number of animals of same kind, same number of animals, same kind. And the third is that largest possible animals. So whatever is the number of animals in each trip must be an exact divisor of 105, 140, and 175. Further, since it has to be largest, it has to be the largest divisor of these three numbers, which is nothing but the HCF. So we are going to find the HCF in this case. And for finding the HCF, we'll be using prime factorization method. So let's do prime factorization. First number is 105. So this is now check in order to find the HCF, as we have to find HCF, HCF has to be something that is common, right? Highest common factor or maybe greatest common divisor. So if you look into the lowest prime is 2, but 2 is not common. As you can see, 2 is there in 140 as a prime, but it is not there in other two numbers. Now, if I see the next prime, which is 3, again 3 is there as a prime in the first, but it is not there in other two. Now coming to 5, 1 5 is common. Not you can see there are two 5s over here, but 1 5 is common throughout. And likewise, we can see over here that even 7 is common and 1 7 is common. So clearly we can find the HCF, and the HCF over here is going to be 5 into 7, that is equal to 35. Yes, so we'll say that the number of animals that has to be taken in each trip has to be what? 35. Now, this is what we got the first part. Now, if I see the second part, what does it say? It says how many trips to be done so that the animals cross the river. How many trips? So here we have to find out the number of trips. I should read it again. It says the how many trips will be done so that the animals cross the river. So what I said is the number of trips is what we have to find out. Now check here what we know. The total number of animals has to be taken out is what? The sum of these numbers, that is 105, 140 and 175. That results to give you how much? 420. Now once we get the total number of animals to be carried out, we also know the number of animals in one trip, which is nothing but the HCF, which we have already calculated as 35. Now, it should be very clear from here onwards that the number of trips that has to be made will be what? We have to carry 420 animals, and in one trip there are 35 animals. So clearly the number of trips that has to be taken will be 420 divided by 35. I can see it's divisible. So let's reduce it. 6 times, sorry. 60 and 7, 5 times. Yes, it can be reduced further 15 times. So we can say that the required, oh sorry, not 15, it's 12. Right, this is 5, 12 times is 60. All right, so we got option A as the correct in this case. So in the next part, it says when the animals were doubled, how many animals could be taken in each trip? So they mean to say that if each animals are now doubled, that means now we have double of 105 is how much? 210. 210 goats, double of 140 is what? 280, and double of 175 is 350. Yes. Now, what we can see that since the number of animals, each numbers are multiplied by 2, right? Double means multiplied by 2. So can I say that the prime factors of these will have additional 2? Okay, if it's not clear, we can once again understand this. 105 factorization was what? 3 into 5. Yeah, 3 into 5 into 7. But then if I say that I have to double this, sorry, I have to double this, that means there will be an additional 2 in its prime factorization. Likewise, if I see that the prime factorization of 140 was what? 2 into 2, 4 into 5 into 7. Now, since we are doubling it, so there will be multiplication of 2 on both sides. So we'll say we additional 2 will be there. And finally, it was 350. No, it was 175, whose prime factorization was what? 5 into 3. No, it was 5 into 7, or the another 5, sorry. 5 into 7. So since we are doubling it, there will be additional 2. Right. Anyway, now we can find out that whatever the prime factorization was there for the previous part, like these numbers, there will be one additional 2. So we can straight away say that the HCF is going to, initially it was 35, and you can observe from here that 1, 2 is there. If this way it is not clear, you can find out the HCF by the usual method. You can see 1, 2 is there as common. 1, 5 is there. 5 is also common. And we have 1, 7 as common. So this much. Yes. So we can say now the HCF is going to be what? The new number of animals that can be taken in the trip will be 2 into 5 into 7. 2 into 5 is 10. 10 into 7 is 70. So this will be the number of animals. I can see we have an option over here. So 70 is the correct answer in this case. So let's move to the next part. So now we have to find the LCM of these animals. So again, we have to find the prime factorization. So I can erase this, let's say. Now this is for the original case, right? The LCM we have to find out is for the original case and not for the new one. So we need the prime factorization for the original number. And you can also observe here that we need to find the LCM and not the HCF. So how do we find LCM? We'll be looking for each prime with the highest factor, like 2 I can see has maximum power as 2, irrespective whether it's a common or not. Next prime is 3. 3 is there throughout one time, irrespective whether it's a common or not. And 5, 5 is the next prime with how many? 2, 5 into 5, that is 5 square. And lastly, if you look for this number 7 over here, 7 is occurring for whether it's a common or not, it is occurring maximum power with 1. So this is how much? 7 into 3 is 21. I'll write 21. And then this is 25 into 400. So this is 2100. Yes, we have an option, that is options C is correct in this case. Right. So once we got the LCM, let's look for the other parts over here. Now, what is the next part over here? Next is what is the sum of LCM and HCF. So it's very easy to get this. We got the LCM as how much? 210. And what was the HCF? HCF was 35, right? Yeah, it was 35. So if I add them, it's going to be 2135. Yeah, this is what option A is correct in this case. I think this much only. We had how many parts? 5 parts. That was the last.